Welcome back. Welcome back. Welcome back. Welcome back. All right. So now we're going to look at multiplying radicals. How do we multiply radicals together? So to multiply radicals, you multiply the coefficients and multiply the radicands. Remember, that's the numbers underneath the radical. Put the multiplication of the radicands underneath one radical. So basically it's doing the opposite of what we were doing up here. So up here we had one fraction, and remember we said we could ultimately write this as 4 times square root of 9 times the square root of 6 underneath one radical, and then we wrote that as two separate radicals. What we're really doing for this is we're starting out with the two separate radicals, and we're going to make it into one. So remember, for example 1 here, remember there's really multiplication between this 5 and this root 6 and the 2 and the root 2. So in your head, if you don't want to rewrite it, in your head you should at least be thinking of this. I can rearrange multiplication in any order, so I'd be multiplying those, rearranging so the 5 and the 2 are together, and then times root 6 times root 2. And then again, what we're saying is you multiply those coefficients. 5 times 2 is 10. You multiply those numbers underneath the radical, put them underneath one radical. Put them underneath one radical. So I end up with 10 times the square root of 12. Now, you still have to simplify the radical. 4 is the perfect square that goes into 12. And that would be root 4 times root 3. And root 4 is 2. And then I multiply my 2 and my 10 and my 2. So it would be 20 square root of 3. For number 3, same idea. Multiply my coefficients. 3 times 4 is 12. Multiply my radicands. 3 times 7 is 35. Put that underneath one radical. Is there any perfect square that divides evenly into 35? And there's not. So guess what? That isn't actually in simple radical form. When you have a problem like number 3, remember these are all separated by multiplication. So therefore, I'm going to, I can think of this as rewriting it as separate radicals. And I'm actually going to do this 3. So as we go to number 3, I'm going to do number 3. Same idea. I'm going to think of these as 3 separate radicals. I gave you a jump start for number 3 there. All right. When I think of this as 3 separate radicals, what perfect square goes into 48? That would be 16. So it would be square root of 16 times square root of 3. Now, right here I'm saying square root of x to the 20th. So what times itself? What times itself is equal to x to the 20th? So I'm saying x to the what times x to the what equals x to the 20th. And remember, that what has to be the same thing. So just remember, when you're multiplying like bases, you add the exponents. So in this case, it would be 10 and 10. So ultimately, you're just going to be taking when you're taking the square root, you're just ultimately dividing the exponent by 2. So I'd have x to the 10th. What's the square root of y to the 10th? So that would be y to the 5th times y to the 5th is y to the 10th. Or, again, take 10, divide the exponent, divide by 2, so that'd be y to the 5th. And then, I have an odd number here. What the heck am I going to do here? So, when you have an odd number, what you want to do is rewrite it as, use your law of exponents, the next lowest even number. So that would be 14, z to the 14th. And then I still have to multiply that by z to the 1st. Because z to the 14th times z to the 1st, you add your exponents to get z to the 15th. So now I just have a little cleaning up to do. Square root of 16 is 4 root 3, x to the 10th, y to the 5th, the square root of z to the 14th. I would, again, divide that by 2, so z to the 7th. And then I have the square root of z left. So that would be my final answer. All right, try this one that I gave you a good start on, and then these two on your own. So for number 1, we'd have 6 root 18, and we would have to, 9 is the perfect square, so I'd end up with 6 times 3 times root 2, 18 root 2. And then for number 2, I'm going to multiply all those 8 times 6 times 3, and I get 144. And lo and behold, square root of 144 is 12. So that made life a little bit easier there. And then for number 3, again, like I said, you write this as 3 separate radicals. Square root of 36 is 6. Square root of x to the 14th, I should divide that by 2, x to the 7th. Square root of y to the 26th would be y to the 13th. And square root of z to the 50th would be z to the 25th. When you are dividing radicals, you are ultimately just doing a very similar thing where you're going to be dividing the coefficients. And again, you can either divide or if you can take the radical on the top and the bottom if they happen to be perfect squares. However, if not, you can make them into one big radical. So what I'm going to do here is I'm going to rewrite this as 9 divided by 3. Then make this one big radical of 125 divided by 5. Again, since the 125 and the 5 were both under the radical, I can then make the 125 over 5 underneath one big radical. And so what that does, 9 divided by 3 is 3, and I can take 125 and divide it by 5. It happens to go in evenly, and that would be the square root of 25 then. And we know the square root of 25 is 5, and 3 times 5 is 15. Now for number 2, 36 does happen to be a perfect square, but I wouldn't know how to get rid of this root 3. So what I'm going to do is very similar to what I just did in the first one. I think of it as 8 over 4 times, and then underneath one big radical, 36 divided by 3. 8 over 4 is 2. 36 divided by 3 is 12. And then I'd want to simplify my radical of 12. So 4 is the perfect square that goes into 12. And I get 2 times 2 root 3, or 4 root 3 is my final answer. All right, try these two on your own. Again, I'm going to do 10 divided by 2 is 5. And then 180 divided by 5 is 36. So I'd have the square root of 36. And that happens to be 6, so I end up with 30. And again, I got that. 10 divided by 2 is 5. 180 divided by 5 is 36. Number 2, 18 divided by 2 is, 16 divided by 2 is 8. And then 60 divided by 2 is 30. And since both the 60 and the 20 were underneath radicals, 60 divided by 20, which is 3, should be underneath the radical. I cannot simplify 3 at all. Square root of 3. All right, that is multiplying and dividing radicals.